Okay, hello everyone. I welcomes to all in our lecture series on fiber optics. In this lecture series, we are going to discuss these topics, which are most essential for B.sc, B.Tech, M.sc, M.Tech, and various entrance examinations. In our today class, we are going to discuss first topic, that is your introduction and basic principle of data propagation in fibers. Okay, so let us start here. This is the introduction part of fiber optics. In short, we are going to discuss fiber optics is a technology that transmits information using light pulses through thin film transparent fibers, typically made up of glass or plastic, called as optical fibers, which are looks like physically like this one. The internal part or the core part is a glass tube like this, and this glass tube made up of two materials. One is your core part and another is your cladding part. Core part refractive index, suppose this refractive index is n1 and this refractive index is n2. N1 refractive index is greater than n2. Why and how, that we are going to discuss later in this lecture series. So this is the physical appearance of optical fibers. So if I am going to discuss in detail, so the core part is a glass or plastic made up of two different materials. Core part is your core part, one is your cladding part. These two part made up of glass, and another coating part is there, this one, which is made up of plastic, which will protect the core and cladding. Then after that, a strength member which is made up of plastic, this one. Okay, and then outer jacket, this one. Okay, by this technology, signals are converted from electrical to optical signals, then transmitted through glass fiber or optical fiber and reconverted into electrical signals. So here, suppose one signal I want to propagate through this optical fiber. This signal first it will be converted from electrical to optical, and then it will transmit from one point to another, and then that optical signal will be reconverted to electrical. This is the procedure. Okay, these optical fiber are used in telecommunications, data networking, and various other applications, offering advantages like higher bandwidth and longer transmission distance compared to traditional copper wire. And here I forgot to add another point, less attenuation of signal. Okay, so in short, we discussed the introduction part of fiber optics. Then we are going to move further towards principle of data propagation in fiber. First of all, suppose one more question will be asked, what, just define the optical fiber. You have to write this much. An optical fiber is a cylindrical waveguide made up of transparent dielectric, that is your glass or clear plastic, which guides light waves along its length by total internal reflection. You can see this one. This is the glass. Here is the light signal propagated through this tube or waveguide by total internal reflection. From this figure also you can understand. Okay, so here the principle of data propagation or light propagation in the fiber is nothing but your total internal reflection. Right? How much data will be propagated through the through these fibers, that we are going to discuss in our next slide. Before that, we are going to just recap what we have been studied in our +2 level about total internal reflection, because total internal reflection is the key point or principal point, you can say, for data propagation or light propagation in the optical fiber or through the optical fiber from one point to another point. Okay, here you can see. Here I consider a high refractive index. Suppose this is a glass, one medium, and another medium, low refractive index n2, suppose air. Right? A light incidence from this medium at this interface with an angle, suppose theta 1, and it will be refracted like this with an angle theta 2. This is your normal, so it will move away from the normal because this is the denser medium and this is the rarer medium, right? This is the theta 1 and this is the theta 2. If I'm going to apply the Snell's law here, sin theta 1 by sin theta 2 equal to n2 by n1, right? Now I'm going to increase this angle theta 1 here. If I'll increase, then the bending of this refracted light will be more from this normal like this. For a certain angle at a particular angle theta c, this refracted light will be on the surface of this medium or at the interface of these two mediums like this. Suppose at particular angle theta c, the refracted light on the moved on the surface of this medium. This theta c is called as your critical angle. Already we have been studied in our +2 level. Now just apply the Snell's law for this case. What we can get? Because this angle will be 90 degree, this angle will be 90 degree. So applying Snell's law, we can found sin theta c by sin 90 equal to same n2 by n1, right? Now again I am going to increase the incident angle greater than that of this theta c. Then what is going to happen? The light, this light will be reflected back in the same medium. Here you can see with this angle, which is here theta is greater than that of the theta c, then the light will be reflected back to the same medium. This is the reflected. We could not get any refracted light when theta is greater than theta c. Here theta, incident angle, will be equal to reflected angle, because this is the incident ray, this is the reflected ray in the same medium. So this is all about your total internal reflection. So for total internal reflection, here incident angle equal to reflected angle equal to theta, and this happens when theta greater than that of the theta c. Just keep in your mind, when the light is moving from higher refractive index to lower refractive index at a particular angle, it will be reflected back to its original medium, and at exactly theta c, it moves on the surface of this medium. Okay, you just keep this in your mind. Okay, so here you can say that with this angle, that means with critical angle, the light will be on the surface of this medium. Just above theta c, it will be inside this medium, right? So this is all about your introduction part and principle of data propagation in fiber. Next class we are going to discuss acceptance angle and acceptance cone. Okay, so thank you so much for watching this video. Thank you.